Periodic table worksheet 2. So this question says, which statement is true about the elements going down group 1? So when we go down group 1, we will see that we are actually having lithium, sodium, and potassium. Lithium has 3 protons, sodium has 11 protons, and potassium has 19 protons. So the proton number decreases is wrong. And if you draw it out, you can see clearly that sodium is bigger than lithium because of the increase in number of protons as well as electrons, as well as neutrons. So therefore, the answer will be B. The size of the atoms increases. Next question. Rubidium is in the same group as lithium, sodium, and potassium. So which statement is likely to be correct? So the first statement says it forms a sulfate, Rb2SO4. So first of all, we know lithium is in group 1, so lithium will be Li+. Sulfate is SO4 with a charge of 2-. To balance the charge, I need 2 lithium so that I have 2 positive charges, which will give me the formula Li2SO4. Since rubidium is in the same group as lithium, so rubidium will also be the same as this formula Li2SO4. Rubidium will be Rb2SO4. So the answer for 2 will be A. Next question, question 3. Lithium is a metal in group 1. So first of all, when we talk about lithium, let's look at option A. Option A says lithium atom gains an electron. Lithium is 2.1, 1 valence electron in group 1, and to make it into an ion, it will lose an electron, not gain an electron. So A is wrong. 2.1 will lose 1 electron to become 2. Next, lithium is less reactive than sodium. So if we draw out the group 1 elements, we know that the most reactive is at the bottom and the least reactive is at the top. So therefore, option B is correct. Question 4, the table shows some properties of 4 metals. Which metal is in group 1? So if we look at the table is talking about density and hardness or softness. So group 1, we always say that it floats on water, being low density. And we always say that group 1 is easy to be cut, so therefore it is soft. So with that, option A would be the answer for question 4. Next question, question 5. So we're talking about cesium, which will give us Cs plus because all group 1 will be plus. And they ask you for the formula for cesium chloride. So first of all, cesium is Cs plus, chloride group 7 Cl minus. Charges are already balanced, so therefore you will get CsCl. The next one they ask for is cesium hydroxide. Cesium is Cs plus, hydroxide is OH minus. Charges already balanced, so you get this answer. For the next parts, what we have is cesium sulfate. Cesium is Cs plus, sulfate is SO4 2 minus. We need 2 cesium to balance the charges. So therefore, you will write Cs2SO4. For cesium carbonate, we have carbonate as 2 minus. So we need another cesium to balance the charge. So we will get Cs2CO3. Next question. Will you expect cesium to conduct electricity? So cesium is in group 1, alkali metals, and all metals conduct electricity. So yes, it is a metal. Next. How many electrons are present in the outer shell of cesium? So since cesium is in group 1, it will have 1 valence electron. So when they ask you for outer shell, it's the same as valence. So there is 1 electron. Will you expect cesium to be more or less reactive than potassium? So again, you draw out the elements in group 1. The most reactive is always at the bottom. So if you compare cesium and potassium, most reactive is at the bottom. So cesium will be more reactive than potassium. Next, describe the trend in melting point from lithium to potassium. So lithium to potassium, we are going down the group. When we go down the group, remember Dr. M. D stands for density, R reactivity, M melting point and boiling point. And therefore, the trend as we go down the group, the melting and boiling point decreases. And finally, the last question for the next part will be question 6, where they show you the melting point and they have shown you this melting point with potassium not having any melting point for you to do. Then the next question says, in part A, is for you to plot a graph. So they want you to plot a graph of the melting point against the metals, marking each point with a cross. And what do they want you to do is, if you look at the graph, it says relative atomic mass. So if you go to your periodic table, the periodic table shows that the relative atomic mass is the number at the bottom. So it will be 7, 23, 39, 85, and 133. This is from the periodic table looking at the bottom of the element. Once we have these numbers, we would transfer the numbers at the bottom here. So this is lithium with 7, sodium with 23, potassium with 39, rubidium with 85, cesium with 133. Once you have done that at the bottom, we will then look at the melting point. So cesium, we will look at the melting point of 28 over on this side. So you will need to put a cross. Rubidium will be a melting point of 39, which will be on this side, where you will need to put a cross. Potassium, we don't have any number, so we skip potassium. We leave potassium alone. Okay, and then we move on to sodium. Sodium is 98. So if you look at sodium, sodium is 98, and we put a cross over here. And the final one is lithium. Lithium is 181. We put a cross over here. So once you are done with the crosses, you will then need to join them up. And they say that we draw a curved line of the best fit. So this is how you draw your curved line. Okay, you need to use a curved ruler, and the curved ruler, you will join up the points all the way till the end. So it will come out a little at this point, and it will come out a little at this point. And then in the next question, it says to use your graph to predict the melting point of potassium. So when you use your graph, potassium is over here. You will need to draw a dotted line up, draw a dotted line to the left, and you must indicate 65 in the graph. And then, because it's degrees Celsius, we then turn back and write down the answer as 65 degrees Celsius. So that's for that part. And the next part, when it says explain why all these elements are in group 1, so you need to understand that those in the same group have the same number of valence electrons. And for group 1, they all have 1 valence electrons. For the next part, describe 2 observations made when sodium is added to water. So we know that sodium reacts very vigorously. So we write sodium reacts vigorously, darts around the water. And also with sodium, you see a flame, and you see a color flame. And the color flame you need to remember is yellow. So sodium is the one that burns with a yellow flame. Lithium burns with no flame, and potassium burns with lilac flame. Next part asks you what you will observe when you drop a few drops of indicator into the reaction mixture, which means the solution that is formed. So the solution that is formed is an alkali. For universal indicator, you have not learned this before, but the colors are red, orange, yellow, green, blue, indigo, and V for violet. Red, orange, yellow are the colors for acid, green is the color for neutral, and blue, indigo, violet is the color for an alkali. Okay, and the color for a strong alkali formed in this case will be violet, which is why they are called alkali metals, because after reaction with water, they form a strong alkali. So you would see the universal indicator turns from green, which was the water, color of water, to violet, which was the solution after the reaction of metal with water. And the final part for this worksheet is to write a balanced chemical equation for the reaction between sodium and water. So the first thing you need to be able to know is what is formed when sodium reacts with water. Okay, so when sodium reacts with water, we form sodium hydroxide, which is the alkali, and hydrogen gas. Once you write the word equation, then you write the chemical equation with the formulas. So how do you write the chemical equation? Sodium is a sodium metal, Na, water, H2O. Sodium hydroxide, you have to use the ions, balance the charges, and you get NaOH. Hydrogen gas is always diatomic, so it's H2. Once you did this is the chemical equation. You need to balance. So if you look at the balancing, if we count, sodium has 1 on the left, 2 on the left, hydrogen, and oxygen 1 on the left. Sodium is 1 on the right, 3 hydrogen on the right, and 1 oxygen on the right. So this is not balanced, and we need more hydrogen on the left. So we'll put a number here, which makes it 2. After you put the number 2 here, you count again, and you will see that there is 1 sodium on the left, 2 times 2, 4 hydrogen on the left, and 2 oxygen on the left. At the right, it remains the same, 1 sodium, 3 hydrogen, and 1 oxygen. So both of these are not balanced for hydrogen and oxygen. So we need to add on the right, and this is where we can see oxygen and hydrogen both at the same time. So we'll add here, and the number will increase to 2. And then now we check again. So when you count, you will see that I have this remaining the same. And here when you count again, you get 2 sodium, you get 2 plus 2, 4 hydrogen, and you get 2 oxygen. And then this is not balanced, and we need to add more sodium on the left. So finally, you will add a number 2 here. And when you do this, you will count, and you will find that they are all balanced. And once this is balanced, then your balanced chemical equation would then be shown as this: 2Na plus 2H2O, arrow 2NaOH plus H2. So in this worksheet, you have learned about group 1 metals and how to apply the content learned into the questions.